Hello everyone, this is Mrs. Lindsay Pereira. We are talking today about factoring. However, before we actually talk about factoring, let's talk about multiplying. And let's review this just a little bit. So we'll go through a few of these. On the example A here, example 1, part A, we want to find the product. Okay, so typically what we would do, we have a monomial times a larger polynomial here. Okay, we need to distribute the 2x to the third, this one here, this 2x cubed. We need to distribute that to every term. Doesn't matter how many terms are in here. Terms are separated by addition and subtraction. So there's 1, 2, 3, 4 terms. We have to multiply, distribute it to all of those. Okay, so you're going to hear me say that a lot. Distribute. So I got to take 2x cubed times x cubed. So the number times the number. So 2 times 1, 2. And then when I multiply those variables together, since they're both x, I add together the exponents of 3 and 3, and I get 2x to the 6th. And I'm going to go ahead and erase this for just a moment, because what happens is sometimes we just do that like I just did, and we lose track of what we've done, or we forget one. So if you do this one at a time, okay, we just did that one. Now let's do this one. Now we can make sure that we don't miss a sign and that we've multiplied everything through. So 2x cubed times a positive 3x squared would give us a positive 6x to the 5th. I'm going to multiply that in the next one. 2x cubed times, and notice I'm going to say a negative 2x. That sign in front is what goes with our third term here. So 2 times negative 2 gives me a negative 4. X cubed times x, add that together, the exponents. Again, that's a hidden exponent of 1. We just don't write it. So I would add that and get x to the 4th. And last but not least, 2x cubed times 5. So literally I just have to take 2 times 5 because there is no x there. So I just bring along the x cubed. Okay, so now when we move on to example 2 here, I'm going to go ahead and do B here. I have 3 terms here, again separated by addition subtractions, and I have 2 terms separated by addition subtraction. It's the same premise as what I did up here. If let me just actually scribble this out for a minute. If those aren't there, I have to take x squared times everything in that second set of parentheses. Again, doesn't matter if there's 2 of them there or 1 of them there. I have to just do that. Take it times everything. I have to distribute. So let's now uncover that. The middle term, I have to do the exact same thing with this one. So again, if I distribute here, I have to take the 3a times every term over here. And last but not least, I've got this negative 4. I'm going to have to do the same. Distribute, distribute. Okay, so notice I'm using different colors. Sometimes that helps. But the more terms, the more times you have to distribute. And we really have to keep track of what we're doing. So I'm going to go ahead and erase this again so I can kind of keep track of what I've done and what I haven't done. Okay, so let's go ahead and we'll just start with this first one. I have to take a squared times everything in the second set of parentheses. So that would become 2a to the 3rd. And then over here, I'd get that to be plus 3a squared. Okay, I'm going to need a little bit more space here. I'm just going to move these guys over real quick. Okay, let me switch colors again. Now I've got to take the middle one times every term. So 3a times positive 2a would be 6a squared. 3a times positive 3 would give me plus 9a. And now I've got my last term. So again, I'm going to switch colors. So negative 4. So again, I got to bring that negative. Negative 4 times 2a, so it'd be negative 8a. Negative 4 times 3 would give me negative 12. Here's also where it's going to differ slightly. I now have like terms where I did not have that before when I took a monomial times a polynomial here. So anything with the same variable, same exponent. So this 2a cubed has no like terms. But now I can actually add these. I don't add exponents. I only add the coefficients in front, so that'd be plus 9a squared. These are also like terms, so I'd get plus a minus 12. Okay. So let's take a look at example 3. Again, same sort of idea. I'd have to distribute. Now I am going to throw a word out here. Some of you might have heard this as FOIL. Some people do not like that word. It's just the order you multiply. However you'd like to do it. It stands for first, outer, inner, and last. So meaning these are the first two terms you multiply. Then you multiply the outer two terms. Again, all I'm doing is really taking this and multiplying it through to everything in the second set of parentheses. And then it says inner two terms. So again, I'm taking 5 times everything in these parentheses and then what I haven't done last. Okay, so again, it's really however you want to do that. Go ahead and pause this video though. Finish this one. Combine like terms, always simplify. When you're ready, push play to check your answer. Okay, so hopefully that matches. Now, as you go through some of these, hopefully you're going to notice some patterns here. The leading term is really formed by multiplying these first two things together. The firsts, so again, the y times the y, whatever, even if there's coefficients in front of those. The middle two terms, so the outer terms that I multiplied together, and the inner terms that I multiply together. Those two always form this middle term. You always typically have to add these, okay? And whatever I did last, so this 5 times the 6, that multiplies to be this last term here. So the 5 and the 6, the last two terms in both set of parentheses is typically this constant. The first two terms is typically this number here. And then when you do, again, what we call the outer and the inner terms, so the outermost and the innermost always form these, which we have to add together. Okay. So again, working on that, we are now going to talk about factoring. What is factoring? It's the opposite of multiplying. You undo distributing. We're going reverse. So notice our answer here is a polynomial. So I'm going to go back to this. This is what I'm saying. This would have been my original problem. And I would say here, factor. And my answer would then be this original problem here of the quantity y plus 5 times the quantity 3y plus 6. Notice this is a trinomial, meaning there's 3 terms. 1, 2, 3 terms here. Again, terms are separated by addition and subtraction. This is how I typically factor trinomials. Okay, people use a variety of ways of doing this. Some people will call it split the middle term. Some people call it curtain, guess and check. I'm going to show you a couple different ways of doing it. And I'm going to try to gear you towards one method over the other, but they all work. It doesn't matter which one you really choose to use. It's what you feel more efficient working with. Okay, so since we are factoring only trinomials here, and again, our goal is to get it to look like these two items here. So 2 binomials, right? So we're going to have 2 sets of parentheses, and we're going to have 2 items in each parentheses. Okay, so that's our goal. Okay, I'm going to talk about what I call the guess and check. Some people call it trial and error. Okay, it's a little easier when you have a leading coefficient that does not have a number in front. So if I was factoring this problem, it doesn't factor, but it would be easier to factor if there's no number right here. Okay, and I'll talk about that in an example we have coming up here in a little bit. But because we have a number here, so again, I'm going to just make our 2 sets of parentheses here. And if you recall, how does this first number come about? Well, it comes from multiplying whatever this first number is and that first number is together. Well, this is a nice number because it's prime. The only thing that goes into 2 is 1 and 2. So I know I have to have 2, and then I need to put a w by it because I have to have a w squared here, and then a 1w. Now, typically we don't write the 1 Doesn't matter if you put it in there or if you leave it in there. Either way is fine. Okay? So now, hopefully you remember, how do I get these second spots? Well, that comes from whatever the multiples of this are. Well, the only multiples, again, it's helpful because this is, again, prime, are 1 and 3. So that means I can either put 3 here and 1 here, or I can switch it. I can put 1 and 3. Well, how do I know? Well, the point is the middle two terms. So when I multiply 2w times 3, so the outer terms and then the inner terms, 1w, if I multiply those should add up to be this middle term. Okay, so let's check it. So if I distribute here, and these are both positive, we don't have any negatives going on here. If I take 2w times 3, I get 6w. If I take 1w times 1, I get w. Those add together to be 7w. So this is my answer. You can always redistribute and check your answers on these problems every single time. Okay? All right, so let me show you another method. This is called, typically it's called split the middle term. It's longer, but it works. And some people prefer it. The more you start working with your number facts, your multiplication, thinking through these problems, this is a slightly quicker method, the more you practice it. So I would try to do this method for number 1, and when in doubt, you can always come back and do split the middle term. Okay, so split the middle term, you do that by taking, first of all, I've got to take 3y squared, so the first and last term together, and multiply them. Now it's sort of similar like this. I have to think about what are factors of 6y that add up to 5y. Well, factors of 6 are 1 and 6, or 2 and 3. Which one of these add up to 5? Well, it's going to be 2 and 3, but I have to put a y by them. I'm literally going to split this middle term into 2y and 3y. It doesn't matter the order. Doesn't matter at all. Going to bring down the last term, going to bring down the first term. Now I do what I call grouping. So I group the first two together, group the last two together. I should have left a little extra space there, so I apologize. I'm running over my addition sign there. Please remember there is a plus right there though. Now I look at the first set of parentheses and I say, okay, what's in common? 3y squared, 2y. What's the GCF I can take out of those? Well, it's a y. So when I take that out, I should say, when I divide by it, 3y squared divided by y would be 3y. 2y divided by y would be 2. Okay? All right, same idea. What's the GCF here? There isn't one. It is literally just 3y plus 2. There isn't one. However, there actually is. It's just 1. It's a positive 1. Okay, so that's why it's important to realize there's a plus right there. Okay, I need to include that sign right there. Could be a positive, could be a negative. Really, really important. Notice what's in parentheses here. In parentheses, this in purple is exactly the same. If they are not the same, something is wrong. Okay, so now my last step is I rewrite what's in parentheses, and then whatever these GCFs are, form my second set of parentheses. And again, if you're not sure, FOIL this out, distribute it back out, you should get your original problem there. Okay? Okay, so let's try some more of these. Those are the two methods that we're going to work with. I'm going to kind of bounce back and forth between the two. I do want to talk about one other item. I want to look at number 6 here. If you look at the original problem and there's something in common originally, like if I could factor out a 2, or in this case, if this is negative, I highly recommend taking out that negative. So dividing all of these by a -1 basically just changes my signs. Now this leading coefficient's 1. If this leading coefficient's 1, all I have to do is find factors of negative 28 that add up to 3. Because the only options for this are x times x. I don't have to think about a bunch of different factors that go into this. So I only think about factors of negative 28 that add up to 3. Well, there's a lot of factors of those. I mean, I could do 1 and negative 28. The negative could switch. If it doesn't pop into your head right away, write down the factors and switch the negatives until you find that one that adds up to 3. And hopefully you realize that we have 4 and 7. If I make the 4 negative, if I add those together, I get positive 3. So that is the one that works. Okay, so much easier problem if the leading coefficient is simply just 1. Okay, and here I factored out a GCFs. Highly recommend, especially if that's negative, factor out that negative number. We will run into some problems though where we want to actually factor out a GCF. Okay, but let's try some more problems. Let's jump to number 11. Okay, so we're factoring here. If I had to guess, split the middle term. Some of you probably want to do that. I'll go ahead and do another split the middle term, and then the next problem I'll do more of a trial and error thing. It does not matter. I'm going to repeat this again. It does not matter which one you do. Okay, if you're more comfortable with one method over the other, please do whatever you're more comfortable with. Okay, so split the middle term. I got to multiply 2x squared times negative 15. So the first term times the last term. And that's going to get me negative 30x squared. Now, what are factors of negative 30 that add up to 7? Again, if it doesn't pop into your head right away, write down factors. Switch the signs too, because this one's positive 29, this one's negative 29. Not what we're looking for, but again, that's how you get the difference between a positive and a negative. I know negative 2 and 15 also work. Is that adding up? Nope, that's not even, I'm not even going to switch the negative signs because that's not what I'm looking for there. Okay, so what about negative 3 and 10? Oh, that one works. This is the one that I'm going to split the middle term with. Doesn't matter the order. I just have to remember to put x's with both of those because the middle term's got an x. And then I bring down the last term and that first term. Now I'm going to group the first two and the last two, and I kind of treat them as separate problems. What's in common here? Well, I can only take out an x. So what's left over? 2x minus 3. Again, I'm dividing an x out of each one of those. Okay. What's in common here? Hopefully you see it's a 5. Please make sure you put the sign. There's a sign here, so there should be either a positive or a negative sign there. Divide it out. 2x divided out minus 3. In parentheses in black here, are they the same? Yes, they are. That's my little checkpoint. And what's left over is the GCFs, the x plus 5. And again, when in doubt, you can distribute this together, FOIL it, multiply, see if you come up with the original. Okay, you can always check your answers with factoring. That's what's really nice with that. Okay, so let's try 13. 4b squared plus 2b minus 2. Okay, so what's a little different about this problem? I see that every term, all three of these terms have a factor of 2. So my GCF is 2. Factor that out first. Divide that by 2, the middle term by 2, the last term by 2. So 2b squared plus b minus 1. Now I factor this just like I normally would. Split the middle term, trial and error. I'm going to go ahead and do trial and error with this. This GCF, it just kind of keeps coming down. I can't drop it off the face of the earth, but in the end, I have to put it as my answer, with my answer, once I factor this trinomial. So again, it's a little nicer because this number and this number are primes. The only numbers that go into 2b squared would be 2b and 1b, or just b. Factors of 1, -1, would be 1 and -1. So I just need to decide, does the negative go here? Or does the negative go here? Okay, well, let's just think about this a little bit. You know, if I go here with the negative and make this one positive, this would be -2b. This middle term would be 1b, so that'd be -b. Not what I'm looking for, so I need to reverse these signs. And I need to make this one negative and this one positive. So now when I multiply, I get this to be positive 2b, negative b, which makes that a positive b. Okay? All right, so this is the end of factoring. Okay, so you have a little quizzes to do, and then your homework again is to finish this note packet and then upload that to Schoology. Okay.